Thank you, Matthias. All right, so as Matthias was saying, I'm the CTO of Get Human. Unlike Colin, who's our second speaker, I am not a data scientist, and it's important that I say that up front because I come at things from a software developer point of view, from like a hacker mentality, and I am super interested in this, but I think all along the way in my talk, I'm approaching it from the standpoint of trying to get people that are potentially good software developers, potentially, or product managers or whatever, and may have heard things about AI, but want to start learning more, want to start getting their hands dirty, and that's what this talk is all about. But it is something that I've had an interest in for a while now. In fact, when I was home for Christmas, this past Christmas, I dug up from my basement this paper from 2 decades ago where I did a thesis at Boston College, actually, on a neural network that I created. And, I've always been interested in the essence, figuring out what the essence of things are. What is a chair? What is, how do you break down the things in our life and in a way that a computer can actually do the same things that humans do? And so let's talk about what is artificial intelligence. What is this thing that we kind of hear a lot about? And in order to talk about this, I want to take a step back and first talk about what is intelligence. And what I'm talking about is human intelligence, the way that we think. And in order to talk about this, I think it's best to, or I can best bring in two of the smartest people that I know, much smarter than me. My 2 daughters, Angelina and Madeline, 4 and 6 years old. For anyone does anybody have kids here? A couple people? Oh, a lot of people, okay. So for those of you that do know that it is amazing how smart they can be, how they can go from knowing like nothing to then all of a sudden in a very short period of time understanding these super complex concepts. We play this really great game between the 3 of us, and 4 of us with my wife, where one of us will make a face, try to display some sort of emotion, and the others of us will try to guess what that is. So, for example, my daughter Madeline will make these different faces, and then we'll first person to say what it is, and Angelina will say, "Oh, sadness," or "happy," or "thoughtful," or whatever. So, the crazy thing about this is it's a very subtle skill, right? It's a very complex skill, but kids do it so well. My 4-year-old, 6-year-old does it really well, but my 4-year-old does it even better than her. Like, she can tell things that other people, like even my wife and I, don't pick up on, and she can pick up on it. So, like, how do you teach that in to someone? It's almost hard to imagine how a computer could do the same thing, right? But now, so that's a certain type of intelligence, a certain type of knowledge. Here's another type. Finding a simple basic math equation, the square root of 49, which 7. But no, this is something that we all probably know very quickly, right? But okay, going back to my daughters again, trying to explain something like this to them is like impossible. Trying to get them to come up with what the answer is here and understand how to do square roots is just totally beyond them. So you kind of compare these two things, basic math and emotions, and let's kind of like go through it kind of step by step of what's involved. Where with input, there's numbers on the basic math side, whereas figuring out emotions, you have this audio, what you hear, a visual, what you see, maybe some other inputs as well. And then in order to process it, from the math side, there's a very simple calculation, right? On the emotion side, you need to make some sort of subjective judgment. And then the output for math is very deterministic. It is the same thing every time. Every time you run that basic math formula, it is going to be the same thing, and it is true. There's no alternative truth to that reality. Whereas on the emotional side, it's probabilistic. I mean, you don't know for sure. Somebody sort of is making a face, but maybe they're faking it. Maybe they're really sad inside, even though they seem happy. There's a million things that could be going on. So the best you can do is say that in all likelihood, this is the emotion that's being displayed, or whatever the case may be. So this side of things is where us as application developers and software developers love to live. Like, we write programs to be deterministic. We want it to be pure. For those of us on the JavaScript side, or I guess programming in general, you want, like with functional programming, pure functions. Things that return the same thing every time. And that's where we can build these like powerful programs that are very robust. It's a totally different thing to think about building a system software that is non-deterministic, where this concept that it might not be right all the time, that it will have a different answer when you run it at different times. And how do you actually do that at all? There's these different inputs, and from the human side of things, we just think of the answer. Like, how do we do that even? So there's a good corollary there, because I think when you start talking about AI and what we're building on the machine side of things, it does try to correlate to the way that human brains work, whereas human brains are made up of billions of neurons. And in our brains, and I'm not a biologist, or if I misspeak here, you gotta give me a gimme here, because there is a correlation here that for the neurons in our brain, there are a certain set of inputs, and when those inputs reach a certain level, then the neuron is fired, and then the impulse goes to another set of neurons. And this is the way that we think in our brains. This is the way that, in many cases, for neural networks with machine learning, it's sort of modeled off of that. So I'm going to go over like a really simple, super simple, and definitely not talking about any of the intricacies that even Colin is going to get into in his next talk about how this can work. So the first thing is that there's got to be a set of inputs. And when we're building these systems to make decisions, that's the first thing we have to figure out, is what is the data that we're using to make our decisions off of. And then those different sets of inputs that go into the system, one of the key parts is that they have a weight assigned with them, a coefficient, a weight, something that basically is saying what the value or what the importance of a particular input is on predicting the whatever you're trying to predict. And then in the neuron itself, it has an activation function, which we'll kind of gloss over since this is like a simple overview. And then there is the output. Of course, this is like, again, simple oversimplification. In reality, just like our brain is made up of billions of neurons, a artificial neural network has usually multiple levels, multiple layers of different neurons that work together. But a lot of the concepts are still the same. You still have set of inputs, weights associated with each of the inputs, and then some sort of output. And one of the keys to this is that when the neural net is making a prediction, so in the case of like classification, which is a type of AI problem that is used very often. So for the game that we were playing, that is a classification game. Like you're trying to predict one of a limited set of items. Like it's, let's say 10 different emotions that it possibly could be. And so the prediction has to be one of those 10, right? So the prediction is one of those 10. And the key to all of this is that you have to have, except for when you get into like deep learning, which will be a future subject, for basic neural nets, you have a set of training data with the actual expected data. So we would, in the case of our game, we might have some recorded audio and recorded video of my daughter making different faces, and we would have the actual truth is, what the actual emotion is in our training data. So this was happiness, this was sadness, this was whatever else. And if you have enough of that, usually a lot of data, usually like thousands, hundreds of thousands, maybe even millions of examples of that data, and you run it through a machine learning system, you can basically take the difference of whatever the system predicts, which at first will be terrible. At first, it's almost random, just like it'll be wrong most of the time. But you compare it to what your training data says for expected, and basically that feeds back into the system in order to update those weights. And so the weights are really the model that is used for making these predictions. And that's what's preserved across, that you take out of it after your training session, and then you use when you actually want to make predictions in a real-time live basis. So the TLD for hackers, because this is sort of the excuse from for people that are coming from the math side and more of the data scientist purists who know so many of the intricacies of machine learning. This is like they're going to throw up in their mouth, I think, when I say this. But the TLDR is really just three things from a hacker point of view. It's just all you have to know is figuring out what the inputs are to your decision point, what the potential outputs are. So define your set of output, and this is for classification in particular I'm talking about, especially. And then have a large set of training data that you can run through. Once you kind of have these things, there's plenty of different variations in the actual process of both curating your input data and how you train your system. But from a software developer's point of view, you can take these things and you can go pretty far with them. All right. So when we talk about using this stuff for real, I'm going to kind of go through some of the landscape and what are some of the, to try to get your mind set on what are some of the types of software that is out there to help with doing this. So typically you start off with your raw input, and for that, that's existing stuff that's out there. So it's either data that's already in your system. So if you have an application, you work for a company that already has a huge amount of data just sitting there. That's a good starting point, right? But you might get it from other sources, either chat, Twitter, whatever else, video, audio, phone. There's a lot of raw data sources. But in many cases, most cases, that raw data isn't what you actually feed into your neural net. It has to be curated in some way. It has to be pre-processed. So especially for something like raw speech. Raw speech has to be translated typically to text, and then text something like NLP to extract out the relevant entities from that text. And so just a couple of quick examples. There's tons of them out there, but something like Speechmatics is software that you could use to do speech recognition, text raiser to translate from once you get it in text to actually pick out those data entities. But there's a million other things, some of which I'll talk about in a second. And then for the machine learning side, Colin's going to talk about PyMC3 a little bit, of something, Python library that you can use. There's also TensorFlow from Google, and again, a million other things that you could use for that sort of black box. Don't do what I did in college and build your own neural network. It is not fun, at least for me. And then there's a lot of platforms that are built on top of it. There's actually almost a proliferation of these AI platforms now to try to make your life easier. Chief among them being Amazon here. They have a great set of services that they just relatively recently came out with a couple months ago with Amazon Lex and a bunch of other stuff that's available to do pretty much all of that stuff at the lower level that you need with NLP, speech recognition, everything else. And then you can use other, I've used API AI before and WIT, and there's a lot of stuff out there. And then sort of the next level up are all these apps that are built on top of these platforms or the raw lower level libraries and software. And a lot of times these higher level apps are either stuff that you are using directly as a consumer, or sometimes they expose an API themselves, like Alexa has their own API, higher level API that you can use to work on their platform. Or it's just something that is good to learn from. One thing with this particular box here is that all of these companies have Boston-based teams. Well, Alexa technically is in Seattle too, I think. But everybody else here is Boston-based. And there's tons of other ones in Boston as well. But I do want to highlight a couple of them from Boston, because I do think it's interesting to know what some of the people in our own community are kind of working on. So CyberReason is a security-based company that uses machine learning to detect nefarious characters within your network. It's actually really awesome what they do, and they're really good at it. And to be honest, even though there's rule-based stuff, like there's plenty of security companies that use rule-based stuff to like figure out, that there's some sort of hacker, in your system. But it's super interesting what they've been able to how they've been able to apply machine learning to figure out that something is not, there's abnormal network activity going on. Milestone, I don't know if Jim is here, but no, there, yeah. So Milestone's a really interesting app, I thought, that from some of the people that are here, that basically allows you to send it a bunch of images without giving it any context, no tags, whatever else, and basically uses image recognition to pick out and understand what's in that image, and then allows you to recall it later using Alexa, where you can ask it questions. Tell me about what happened last week, or tell me a story about my mother, or whatever else. Really interesting stuff you guys should check out. Nutonomy, one of a number of different autonomous driving companies right here in Boston, using obviously a ton of machine learning to help facilitate the autonomous driving. And then, Get Human, my own company, uses it to some degree. And this is something that, we built a lot of our systems, without machine learning, without any AI, and are starting to kind of like work that into what we're doing. And I think, if I had to like pick out like a couple like learning lessons for specifically kind of application developers that are starting to look into this, I started to think about that, and I kind of have a list of like 5 things that I think are kind of important to understand it. We kind of gathered. So one is that if you are thinking about that you could build something without AI, build it first without any sort of intelligence. Just use rule-based, like hack it, pretend. It doesn't matter what you're trying to do. You can always create a non-AI version of whatever you're thinking of. Even like, so chatbots, for example, like the majority of them are not intelligent, really. Like they're just silly, like rule-based systems that usually are actually pretty bad if you tried any of them on Facebook Messenger or anything else. So try building without AI first. Understand your user, understand what you're trying to build, and then figure out what are those key decision points that will be vastly improved by adding machine learning, by adding some AI-based technology. And then even before you start adding that, though, you can start recording data. Data is the key to everything. Especially with as things are moving, maybe not right now, but it's inevitable that the underlying technology used for AI is going to be like pretty commoditized at some point. So like even today you're not going to build your own neural network, but in the future you probably won't build any of the kind of pipeline to facilitate intelligence. But what you do need is all the data. You do need to figure out what you're actually using it for. And you can start gathering that even before you actually have AI driving your system. In fact, I would say it's a necessary predecessor, because you need it to like actually train your systems. And study other apps. Typically with most of the stuff that people are doing, especially if it's like us, virtual assistant based type stuff, we do virtual assistants for like customer service. And so there's a lot of similar stuff out there. You can see what other people are doing. You can see where there's gaps and opportunities. And definitely, I wouldn't go for most people unless I know there's a lot of MIT people here that are very smart and can probably jump right into TensorFlow or something more complicated. But at least for me, not coming from that background, it's much easier to start off at the platform level. Start off with something like API.ai, which is like really holds your hand and makes it much simpler. And then as you kind of like advance, you could start to like get down in complexity and try like more and more like closer to the metal. Hopefully you don't have to get to the point where you're running your own NLP parser, but at least start high and then start working your way down. And then, level up as needed. So that's sort of what we've been doing, where we started off with API.ai, and then started to move to just more of the just AWS services, and you can kind of go down from there. Maybe you do need, for one reason or another, to actually implement and host your own version of TensorFlow for some reason. So it all depends on use case, but I would definitely not start there. So one final thought, and then definitely move over to our other two great speakers that are here tonight, and that has to do with you guys, with Boston. So Matthias did a great job mentioning why we formed this group and why we wanted to bring everybody together. And I think I wanted to expand on that just a second more. And really, Boston has something special. We have a lot of schools in the greater Boston area, a lot of smart people that are doing really advanced stuff. Like, it's amazing to see, both in the startup scene and the larger companies, the types of stuff that people are building. And both Matthias and I see that on a regular basis. And I think when it comes to AI, it's sort of in a somewhat nascent state, right now, in terms of application developers actually using it. I don't think most software developers in Boston actually have hands-on experience using a lot of machine learning based technologies. But we want to change that. We want to get people, because I think it will be a core skill of both software developers and product managers, in the future. And so that's where we want to kind of build this community around you guys. And so definitely visit bostonai.org, join our Slack group, and that's it. Thanks a lot.